Welcome to Azure Essentials. In the next few minutes, we'll guide you through your options for compute and how you can increase the efficiency and reduce the management effort of running your apps by moving from virtual machines to container-based and serverless architectures in Azure. This is important as you think through how to onboard compute resources when moving an existing application or workload into a VM or set of VMs in the cloud, or when selecting the compute power you need for new workloads. The good news is that we've designed Azure to allow you to comfortably run the vast majority of your Windows or Linux apps and workloads and only pay for what you use. Let's start with compute in Azure. Firstly, Azure VMs give you access to the latest hardware advances. Secondly, virtual machines can be deployed and managed inside of a virtual network. This model is the closest to a traditional on-premises environment, except that Microsoft manages the infrastructure and you still manage the individual VMs, including patching, upgrades, app scaling, and high availability. You can lift and shift your applications or workloads onto a VM or VMs in Azure without needing to re-architect them or write new code. If you're migrating several VMs or a complex system, then you're going to want to use tools like Azure Migrate to help you assess the VM and IaaS compute resources needed to migrate your existing virtual machines or multi-VM environments first, which we'll cover in an upcoming Azure Essentials. As you spin up your VMs, Azure offers a large catalog of predefined first and third-party reference VM images that you can deploy, or you can define your own from within Azure or deploy images that you've already got. If you're setting up dev test environments or new production services using multiple virtual machines, you can use pre-built Azure Resource Manager templates to hydrate these environments or author your own templates. Azure offers a range of VM types differing in the power and performance they offer. These range from basic entry-level to burstable, which is useful if you have web front ends and need to plan for sporadic compute for traffic spikes, to general-purpose VMs with our D series, and all the way through to our F series for compute-intensive applications utilizing the latest Skylake processors, and our L series for storage and high-throughput workloads. Our memory-optimized M series is geared towards SAP-based workloads with up to 128 cores and 4 terabytes of RAM, and we're continually updating our GPUs to support the most graphic-intensive workloads with our N series, which also supports InfiniBand connectivity for low latency and high throughput. And our H series for high-performance computing allows you to run some of your most demanding workloads. We also give you the option of purpose-built infrastructure with up to 20 terabytes of RAM built for specific workload requirements such as SAP HANA, or even a supercomputer infrastructure in partnership with Cray. And you can learn more about what we do for high-performance computing in a dedicated Azure Essentials overview. You can change the size of any VM at any time. You can, for example, scale up capacity, and equally you can reduce compute power as you need to. Scaling out your VMs in IaaS is made possible with Azure VM scale sets, which enable you to add or remove VMs automatically based on the metrics and thresholds that you set. Grouping 2 or more virtual machines together in an availability set will protect your workloads against downtime. Azure will automatically place virtual machines in the same availability set across different hardware resources to avoid any single point of failure. Azure now operates across 40+ regions globally, and alongside availability sets, Azure provides several other options such as Traffic Manager, availability zones and regions to make your applications highly resilient, available and scalable. So that covers the virtual machine compute power and the global coverage available in Azure. Now, to achieve greater efficiency and utilization of your compute resources, what we call density, Azure also offers support for containers, which offer a consistent way to package and deliver your apps with minimal code changes. To understand their advantage over traditional VMs, it helps to first understand the difference between VMs and containers. With virtual machines, we virtualize the hardware, creating the illusion that there's a machine, each with its own guest OS. With containers, on the other hand, we virtualize the operating system. We share the host OS and create an isolated OS instance for each application. This, in effect, is what allows you to achieve more density, as the app within the container is not necessarily using the whole OS or emulating hardware as a VM would, but just what it needs, allowing you to run more apps and processes on a container host. Now, because all OS dependencies are packaged up in the container, containers also run more reliably and allow for faster app delivery with near instant start times versus the boot up and specialization times needed for a VM operating with a full guest OS. AKS in Azure is a service that helps you create, configure, and manage a cluster of virtual machines that are pre-configured to host container applications. It serves as a built-in container orchestrator for your environment. And the orchestrator, as you can see here with Kubernetes, not only allows you to scale out containers almost instantly, but it also offers built-in management. It manages cross-container dependencies and allows you to tune health checks to automate load balancing and instantaneous app recovery in the case of app failure. You can also complement AKS by spinning up containers on demand without needing to provision a host VM or know anything about orchestrators using a single command in Azure CLI. This is useful in burst compute scenarios, where instead of having to schedule additional VMs, you can use ACI for compute on demand to give you additional capacity during spikes in workloads. And if you're new to containers, ACI is a good way to get started. As you can see, the more you adopt cloud-optimized architectures to modernize your apps, the more Azure can take care of efficiently managing your underlying infrastructure and compute resources. The ultimate abstraction of underlying infrastructure is serverless compute, for on-demand, pay-by-the-sub-second compute triggered by events happening in real time or on a schedule. This is useful in cases where you don't need dedicated compute resources. So now you don't have to worry about density or predefining your compute resources up front, or the operational complexity of running applications. You just write or bring your own code. You can use Azure Functions to fire up compute resources as they're needed and as part of a defined and automated visual workflow through Logic apps. Most of the time, I don't need to write code for the orchestration or to integrate with specific apps. There are already over 150 plus connectors available today for popular SaaS applications. You can bind your serverless apps, for example, to listen to events from Salesforce and Dynamics. You can also push or create data into any of these connectors. Also, if you've got apps that perform frequent polling, you can convert those apps to use eventing with Azure Event Grid. Azure Event Grid offers an automated managed event routing platform for serverless apps, and even apps running in VMs or containers, helping you to save on CPU and networking cycles. It works by allowing applications to send events when state changes occur using push notifications. As events are received, Azure Event Grid facilitates a triggering of programmatic actions via event handlers. And one last option to be aware of, if you're building web apps, you can also take advantage of the app service, which offers many serverless advantages, including security, load balancing, auto-scaling, and automated management as a service. This is a great option for hosting websites and web apps, REST APIs, and mobile backends without being an expert on the infrastructure or management to run your app. Before we end though, there are a few more Azure services worth mentioning as you optimize your compute utilization. First, it's good practice to monitor for underutilized VMs. At a subscription level, you can determine which to shut down or resize with Azure Advisor. Equally, Azure Cost Management helps you track VM sizing and corresponding resources across subscriptions and cloud services. So that was an overview of your options for compute and how you can increase the efficiency and reduce management effort of running your apps by moving from virtual machine to container-based and serverless architectures in Azure. You can learn more from the learning experiences link shown, and of course, keep watching Azure Essentials for even more introductory topics. Thanks for watching.